So I have dedicated the first two lectures in introducing the basic notion of object-oriented programming and C++ language, and you will also get to practice a bit. So in general, when you are given a problem, then the solution comes in the form of what steps to take uh, to, to try to solve the problem. But when you take those steps, it may not be the best form to express that, okay, you just write the function and then the function does what you want it to do. But in order to have good software, you need to have a clear notion of what interface of the software to expose for the user. Like for example, if you are buying a new car and you go to the store and then they start explaining to you the details of the internal combustion engine of the car, and then they just mandate that you would have to learn all these details before you can drive the car, then it's going to be very challenging for us to drive such a car. One of the reasons we are able to easily drive car because the interface of the car is quite straightforward. But behind the scene, there are very complicated arrangements that are facilitating the car to move. So writing object-oriented code is almost like that. So in the C++ world, everything you can think of like an object. This process is called reification or objectification. So one of the simple way to see what is an object and what is a function, I like to share this, that when you are reading a problem, or at least thinking about what are the different pieces that are going to interact, when you find nouns, right, in your problem, they roughly correspond to the objects. And then the verbs, which talks about the different actions that need to be performed, they roughly correspond to the member functions. In other words, so typically in the object-oriented world, you would be thinking everything in terms of the objects. So let's learn some basic terminologies here. So object-oriented programming. So as I said, C++ is an object-oriented language. So what is an object? So let's define. So an object is a repository of data. So for example, a simple repository could be just a shopping list. So in the shopping list, you may have different items coming through. Some milk, vegetables, and so on and so forth. So here, when you are making this list, you may call it my list. So this my list, in that case, is essentially an object of type shopping list. So therefore, shopping list in this case is what becomes a class or a type of object. And you can create now different kind of instantiation of this class, or you can make object that belongs to this class. So this is my list, but your friend may come and then they can create their own list. So therefore you can say, I have another list that's my friends. list. And they may have a set of things in there. So in this way, you can see that once you have defined a type, then from there you can derive different kinds of objects from there. And that deriving of different kinds of object is what is called instantiation. Okay. So this creation of my list of the class shopping list, this is what is referred to as instantiation. So therefore, what is a class now? Class is a type of object. So for example, there could be different types of list. So you can have shopping list is a class, but that shopping list is significantly different from a shopping cart. So these could be two different types of objects, and therefore they can be different classes. So then what are the member functions? Or often referred to as methods. So they are functions that operate on an object or a class. Now, why I wrote here object or a class, because later on you will see there is a keyword called static. When that keyword is present associated with member functions, then that function operates on the whole class, and it is not dependent on the specific instantiation of the class in the form of an object. Okay, I think I gave a lot of definition. Now let's just start making it more practical now.